Hello and welcome, and thank you for joining me in my shop. Today is June 21st. Looks like a gray sky day. Not so hot anymore. Still warm, but not as hot as it was. And maybe we'll get some rain. Rain everywhere but here, it seems. It looks like we might get some rain today. So, okay, what about these two radios now? So I want to continue changing capacitors, comparing the two radios, performance, the way they're built and stuff like that. Just see what we can see by looking at these two nearly identical radios. So I'm going to flip them over. This is the broadcast one here. And something here I'm looking at that I can't figure out. One came in this morning, this capacitor sitting here. What's that out for? I don't remember. Yeah. And so look at these two radios. Let's put them like that. So I've replaced this one, but it did not replace that one. What happened there? I don't understand what I did. I guess, you know what I did? I was making it work. That's what I did. Okay, never mind. Never mind me. Ignore me completely. What to do today? So, it's not a mistake to change this one. This is across the power line. I think that's across the power line. Doesn't look like it, does it? I'm all confused here this morning. Holy smokes. How about this interesting thing? The big capacitor here. There's no capacitor over here. There's the one I replaced. You can see those. What happened to this one over here? So in this radio, this capacitor is installed over the top of the tube socket. In this radio, the same capacitor has been installed down around in here, so you can see a bit of it right there. I don't know. They just make. I don't know how much control a factory puts on its workers when it's building one of these things, but my impression would be they build them exactly the same every time. So a little change like this must reflect something. Of course, these are two different radios coming down, perhaps down two different assembly lines, or maybe down one assembly line. Most of the radio is built that's identical, and then it splits off into two assembly lines. And so different people are doing it. Maybe that's how these changes occur. As simple as that. The other thing is this great big resistor here. Where's its brother? So this big one must be the same as this one. I already went over that. Okay, just waking up here this morning. Let's look at the schematic. I have a particular capacitor in mind that I think we should go after next. Let's look at the schematic here, or I should say schematics. A couple of capacitors to go after right away. One is this one, which is right across the power line, which I mumbled that I thought I changed. I think what's happening here is I've just done too many similar radios, and I'm getting things mixed up in my head. So this guy, though, is right across the power line, and there's another, in the other radios, the very same thing, another capacitor right across the power line, different size, a 0.025 instead. Another one that's worth going after is this one here. That's right across the output transformer. I think, and I could be wrong about this, by the way, that 25 volt rating goes with this capacitor, not with this one. I think these guys take a beating in a radio, I think. Their job is to get rid of any high frequency harmonics that have made it through the radio, or maybe even been produced in this tube, and to try to keep them from going through the transformer and heading for the speaker. That's the purpose of it, I believe. So we have this guy and we have this guy. Why don't we go after this one first? 'Cause I think I've done one in one radio and not in the other. So we look at the other schematic. We have a photograph that goes with it. Whoops, get the number first. C22. So we go to the photograph, very helpful photograph, and find C22 is this one. It goes from the tube socket to the tube socket. And I've already changed it in one radio, and I think we're going to change it in the other. So I've changed it in the broadcast radio, which is what we're looking at right now. So I don't have photographs that go with the other radio, unfortunately. But you think it would be in the same rough position. And the size in this case is 0.02. So this is the one I've changed. And here's the one in the same position in the other radio. This supposedly is a 0.02. That's pretty big. This terminal's pretty certain to be grounded because lots of stuff hooked up to it. The terminal's extended with an open wire this way. Lots more stuff hooked up to it and a black wire. Well, you can see it going right to the capacitor B minus terminal here. Put the clip lead on before I forget what I'm doing. 0.02. Well, it looks like somebody's roughed it up to read the value here. Ooh. I think I wrecked it. It seems like a pretty physically large capacitor here. Oh, this isn't working out. .02. You can read it right on there. 0.02. Okay. And what's the voltage rating on this? Is it something spectacular? 600 volts. 600. Okay. 0.02, 600. We'll put one in there. Okay, let's check out this capacitor here. It looks like it's in good shape. Like it looks well sealed, wax is consistent on it, looks good. Let's see. 50 volts. Nope. Looks good. It's not. It's not. Okay, good. That's good. Now, I think I mentioned the next two capacitors were across the output transformer primary, or if I said something like that, no. They're both going from the plate of the output tube to the B minus. So they're doing the same thing I said. They are taking I can't think very straight this morning for some reason. Did I get up too early? What's up there? Back down here. Yeah, object is to quell any harmonics and stuff like that, high frequency stuff that might be still persistent in the radio output before it gets to the speaker. So that's that one and that one. They're both 0.02, and away I go replacing those. Okay, I've got those two capacitors installed and I've got the removals here. This one is coming from the broadcast only radio. Let's give it a test. a little bit on an angle there. Did you watch Batman when you were a kid? The original Batman? They had those weird angular shots during their fight scenes. Okay, here we go. Are you any good? It's opening up just a little bit. So not as bad as some of the others, but bad enough. Now in the position it's in, it may not have mattered. A little bit of leaking was going on there. Like in some places, a leak in the capacitor, like the grid blocking capacitors I did yesterday, a little leak, big deal. Other locations, a little leak, who cares? Okay, what about this one? This is from the other radio now, doing the same job. Oh, that's not right. Make sure we got a contact there. Oh! So there's an open circuit in this capacitor. Now I may have done that in removing it. I may have broken the capacitor. I was just tugging on this lead here. I may have ruined it right on the spot. It may not have been open circuited in the radio, but this raises an interesting question. Oh, yeah, not my ceiling. How would something like this test? Let's find out. I think it's going to test it as a picofarad capacitor. That's what I think is going to come out of this. Am I absolutely certain it's just an open circuit, a lead contact problem? No, I can't be certain. What are you certain about these days, anyway? If you ever were certain about anything, you were foolish. No unknown or damaged part. Well, okay, that tells a story. Okay, well that's good. We got this guy out of there. Now, assuming this is there but doing nothing, it's open circuited, so it's as good as nothing there. Operating the radio with this capacitor not in place. If there are harmonics coming through, then they will be allowed to pass into the output transformer and head for the speaker. How big a deal is that really? I don't know. To be honest with you, I don't know. Supposedly these things are above your hearing, so what would it matter? Just a waste of energy. Perhaps, and your speaker can't reproduce them. I'd be surprised if it could reproduce anything. So I'm not really clear on just what the urgency is for those capacitors, but we've done them now. Okay. I don't think we should test the radios just yet. I think I should carry on and do another one. So another one that might be critical. What would that be? A critical one. So I did this one earlier in this radio, and its buddy is sitting up here. Maybe I should do it. Get these radios in a similar condition again to what they were. Just noticing I've got two wax guys here. Here I got one molded and a mica. Are they the same? They're coming from the, let's see, they're coming from the volume control. One of them is the same. Okay, yeah, why don't I do that? I will find the matching capacitor for this one over here. It's probably this guy in the back, and I'll change it so the radios match again as much as they can. I mean, they're not identical radios. Okay, that's the plan. That's the plan. Okay, so I just noticed another difference here that could cause somebody some trouble, almost cause me some trouble. So, identical tubes, identical location, and if you look at the key, so you know which way the tube has been rotated, like this tube, the key is here, and over here, the key is here, in the same place. This tube is the same as this tube, the same as this tube, like they're all the same between the radios, except this one. this tube here, the key is pointing that way, and in this radio the key is pointing this way. Yeah, and that's exactly what can happen to you if you don't realize it. As I was comparing the two of them and going after this capacitor, I'm noticing, wow, it's not hooked up to the same terminal. What's going on here? Well, it turns out the tube is in a rotated position, which I would not have guessed. I would not have imagined. There you go. Okay, I'm going to change my approach here. I can't find a decent capacitor to replace this one. And in this radio, there's still 1, 2, 3, 4, 5 capacitors left to do. In this radio, there's only one wax capacitor and this molded one, if I care to do it. Just 2 more capacitors. This radio is finished. So I think that's what I'm going to do. I'm going to finish this radio off and today, and maybe test it. And then tomorrow I'll focus on this radio, or maybe I'll finish this one with the alignment too. I'm not sure. Who knows? One step at a time. You only have to think one step ahead. That's not very strategic though, is it? So we're going to go after this guy. What is it? What is it? Let me find out what that guy's up to here. Let's find it on the schematic. Okay. So this capacitor is this one right here, C12. It looks like a .05. I can read it right on it, 0.05 in the radio. C12, 0.05, 400 volt. Now what's it doing? C12, what's it doing? Oh. Somewhere in here is a schematic. Here we are. So looking for C12, C11. That's the one I just did. C13. Where are you? Here's C12. Oh, look at that. So this particular capacitor is sitting between the B- line and the AVC line. See, it's the AVC line because you can recognize it right away. It's got this, what no doubt is a big resistor here, probably a megohm or something like that, and this line goes right up into the detectors up here, these diodes. So it's picking off the audio and sending it through the volume control and setting up or capturing, maybe is a better word, or utilizing a DC voltage that builds up here, a negative voltage. It looks like it's dividing it here and then sending a portion of it through this Whopper resistor over here. There's no current flow in the circuit over here. There's no current flow through this resistor either because it's just going to a grid. Likewise, there's probably another one here, yeah, going up, around, and all the way through to the grid. And that's it. So the first 2 tubes are volume control tubes. Their grid bias is going to vary based on the strength of the signal coming out here. Stronger the signal, more rectification, more DC, negative DC, more negative DC on the grids of these 2 tubes. And these tubes, it's not a coincidence that the more DC makes them quiet. These tubes are designed to enhance this effect where you increase the negative bias, you decrease the gain in the tube. So sometimes I think these are often referred to as remote cutoff tubes, I believe. Okay, so we're going to go after this guy. He's important. C12. Yeah, I'm going to look at the diagram again. Make sure I got him here. Where'd he go? Here he is, C12. Okay, let's replace this. Oh, did I even consider what would happen if it didn't function right? It didn't function right. C12. Wow, my memory is I'm really bad today. Here we are. Oh, okay, right, it's the AVC. Holy smokes, I gotta stop and drink more coffee here. I do feel a little sleepy today, in fact. So if this guy's not working, first of all, let's say it's like the last capacitor I tested. There's nothing here. So if you have nothing here, then the AVC voltage is going to mirror the voltage coming out of here. And part of the problem is, in this case, I mean, you're feeding basically the output right back into the input. That sounds like feedback. Absolutely, that's what that would be. You'd probably get a weird motorboating effect here, where the radio would put, 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 something like that. Especially if there's still a little bit of capacitance left here. If it was completely gone, it might be a howler. So that radio just howls, and you tune it and fool around with it, and the howling changes, but you can't get rid of it. I think that's probably the effect of not having this. I could cut this out and operate the radio and see what happens. See if I'm full of crap. Yeah. Why test the radio when you can test yourself? I'm going to cut it out and operate the radio. We'll see what happens. Just standing here wondering, gee, should I have the radio operating and then I'll cut this capacitor out and we'll see immediately what the difference is. Ah, sounds like an okay idea. Make sure I'm plugging in the right radio here. Okay, you know what I forgot? I didn't turn on my antenna booster. I think we're going to want to have a nice strong signal here for receiving. So I'm going to have to run and turn on my antenna. Okay, let's see. So that would be on, turned up a little bit. My plan is to tune something in, a station in, maybe tune either side of it a little bit to get away from having a station. And then here we go. Oh, hopefully the radio still works. I mean, I did change capacitors, and this is the first time playing it since then. So we'll tune in and out of a station. Try to hear the effect of the AVC. Ooh, if that makes any sense. Well, it's a very loud radio now. It's too bad that other interference is there. What if we tune up higher? Nope. Okay, we'll use the French station. So the way to hear the AVC is to pay attention to the noise, and then tuning in and out of the station, the noise will go up and down, and that's the effect of the AVC, making the radio more or less sensitive. Let's see if that works here. So the only noise we can hear is this terrible buzzing. The buzzing itself will be generating a certain amount of AVC voltage. We should measure the AVC voltage while we're doing this. Yes, we should. And you can listen to the noise there in the meantime. Okay, so I want to put this onto the B minus. B minus point. One that's safe to connect to. Pretty hesitant here. Right around to here. Okay. And then we're going to want to read AVC volt. You know, we don't have to listen to that, for crying out loud. Okay, let's see if we can find any AVC voltage over here. Nothing. Let's tune something in. So you can hear the noise disappears. The guy's voice replaces it. That's the radio sensitivity going down. Any AVC voltage now? Oh, it's next to me. Maybe I'm reading the wrong spot. DC minus. maybe this capacitor is bad. Maybe that's part of the picture here. The other side, maybe I'm on the grounded side. That's what I'm doing. Duh. Let's go on the other side here. There we are. Okay. Got the meter reading. I have to work my way through all the possible mistakes before I get to the doing it right part of things here. Okay, we're gonna clip on here. A little too wiggly. Okay, here we go. Okay, watching the meter now. Tuning the radio. There's the AVC voltage. Very good. You know what else we might want to do? We might want to look at this on a scope. Because the idea of this capacitor also is to get rid of any RF signal that might be making it this far into the radio. I mean, we can't have any RF making it back through the tubes. There's usually another filter arranged closer to the detector. Let's take a look on the schematic for a second. Maybe I'm going to put the scope on here. Okay, orienting myself. This is the capacitor we're fooling around with. Right now my voltmeter is hooked up right here, and we're reading a negative voltage that's being applied to these two grids. And the voltage going up and down when I tune the radio, because the signal is going up and down. It's getting rectified here. So there could also be our undesirable RF. So here we see a filter capacitor right here coming from the rectified output. The audio is here too. So here comes probably a fairly small capacitor. It's got these two resistors working with it, and the idea is RF dumped. You got this other one here. This is going to the chassis, so I don't have to worry about that. So if this guy is successful, there's no RF left in this leg. But if he's not successful, there could be some RF coming down here. It would find its way out. So we could look for RF here, and then we could look for our RF radio frequency signals here with a scope. And then we could cut this capacitor and see what the heck happens. Plus that sort of steers me towards changing this one too. I think this is still original. This might be a mica C6. Let's take a look. C6, probably a very small capacitor. C6 mica, 100 picofarad. So a very small capacitor. Where are we going here? So this one's not likely to have a problem. So this is likely to be operating properly. So it's likely to be very little RF that makes it here. But why not look for it anyway? My scope will react to the DC side of things too. So we'll hook the scope up right here. Okay, that's good. Okay, the oscilloscope I'm talking about is right here. Okay, very important. All grounds to the same spot, whatever that spot might be. So I'm going to connect this. I wish I had a better place to clip it. Boom. There's going to be a boom out of there pretty soon. How about here? That's probably going to do it. Okay, so we want to look on the scope here. And we want this to be a little less sensitive. And we want it on DC to start with. We'll see the DC voltage. That is right here. Whoop. No, we won't. Why are you not jumping? Why? Oh, this wasn't good. My control switch was actually between settings. Let's try it out. There we are. Okay. We'll set this to, let's say, 5 volts per division. I can't remember what was the voltage. It wasn't that much, was it? And we'll compare the meter reading and the scope reading here. Okay, first of all, checking the 0 on the scope. It's right on. So, one division claims to be 2 volts here. 2 volts, and on the meter, I'm on the 1.5 volt scale. Oh, it's nowhere near 2 volts. I'm trying to watch this and that at the same time here. It's a little hard. They're both fluctuating. I'm trying to see if they're fluctuating the same. I mean, they should be. They're the same reading. Am I not? Am I not doing the same thing? Sure I am. Well, that's interesting. 2 volts on here, but only really 3/4 of a volt here. Or am I reading this wrong? Oh, I'm reading this wrong. Okay, 5 volts. My mistake. Now we get it sorted out. 5 volt scale, 2 volts, just over. 2 volts, just over. Okay. Things are adding up. So we want to know if there's RF showing up here, and we also want to look a little further up in the circuit and see if there's any RF. I don't see anything on here. How could we possibly see it? First of all, we'll put this on AC. And we'll make this a lot more sensitive. Now, what you see in the camera and what I see are totally different. Or not totally different, but I see some distinct lines in here. You just see a band going up and down, but I can see distinct lines and stuff. So you can clearly see there's some audio happening in here. And some RF, because it's a band. You can see, you can get the idea that there's RF better with what you see than with what I see. So not all the RF is gone. Now what are we down here? We're 20 millivolts per division. It's a very small voltage. Tune the radio. Let's tune the radio and see what happens here. Okay, so we get into the middle between stations. There we are. Okay, no stations here. Turn the sound down so you can see. This is RF. I think if I zoom this out, we'll start seeing the individual. Ooh, what a schmozzle that is. Yeah, some very sharp peaks here and very high frequency components. How is that for real? Can't say I've ever really studied this kind of stuff. Okay, so we can cut the capacitor out now and find out what kind of impact this has on my YouTube channel. Wait a minute, just gonna tripod into a little bit of a better spot here. Kind of get an eye on all things. Okay, so 2 volts was the peak. I'm going to cut it out now. I don't know what, the radio might just go bum, 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 and I'm going to have to just turn it off right away. I'm nervous. I got my cutters. I don't think anything bad can happen. Hand on the power control. Just in case. I got the dim bulbs in, don't I? Yeah, I do. Yeah, there's no reason to worry about what happens. Here we go. Wow! Oh, look at the scope. Oh my gosh. No sound change. Well, that's very different now. And again, I'm sorry you're seeing it the way you're seeing it. It's just not going to come across on the camera here. This has gotten quite interesting here. It's not at all what I would expect, and that's just perfect. Let me set up another camera here and make this a little better for you. Okay, there we go. Now you can see what I'm seeing, and I'm going to reconnect the capacitor here as best I can. You can see it reconnecting, everything disappears. I'm going to make I'm going to reconnect and make things more and more sensitive. That's what we were looking at before, far more sensitive. If I take it off now, whoosh, she's full, screen full. Careful what you're doing there, Jim. Take it off, put it on, take it off, put it on. Now, the meter. Can you see what the meter's doing here? No, because you're looking in another camera. There. Okay, so what I'm doing is I'm grabbing the end of the capacitor with a pair of pliers and then pushing the pliers up against the old wire. Like that. See, the meter will go down and up. Just a tiny, tiny amount. Now, let's go tune in the station. This is with no capacitor in place. Now I will turn it down a bit. I will now connect the capacitor again. Okay, now on the scope here, I'm going to flip it to DC. You can see basically one division. I'm now going to connect this capacitor. It's just taking out the audio. Now you think, wow, that audio is actually going right on the grid of the tubes, but those tubes are RF and the circuit is RF and the audio is of no consequence coming out of the speaker, like we're not getting feedback or anything like that. But surely that's not a desirable thing. The other thing about this is supposed to settle down the AVC. I thought it puts an AVC delay in. The idea being that if there's a sudden pop, maybe somebody turns a light on or something like that, a sudden pop won't cause the radio to quiet down very much because there's a capacitor here that will absorb the extra voltage that will be generated by the detector if there's a pop. So if somebody turns a light on, your radio doesn't go down in volume and then slowly come up again. I don't know, is that all true? That sounds good to me. So what happens now if I bridge that? Oh, new experiment coming. We're gonna put in the new capacitor and bridge it in and off, like connect it and disconnect it. So I'm gonna get things together to do that. We'll continue the experiment here. Okay, so we're fiddling. This is the AVC capacitor. I've cut it out. Fiddling around with it, not knowing the condition of this capacitor. So I'm hooking it up and disconnecting it. Seemed to be doing its job to me. Let's see. Okay, so we're on the 50 volt scale. What do you got? You're no good. So because it's leaking, it doesn't really mean it has no capacitance, but the capacitance is being shorted out by internal resistance. That would serve, I would think, to just kind of reduce the AVC voltage. It's in a circuit that's very high impedance, which means a small leak could have a bigger effect than might be expected. There's my ceiling again. By the way, there's all my magnetic stuff I keep up there on the ceiling. Yeah. So I'm going to get a new 0.05. We're going to set it up so I can click it in and out, and we'll experiment a little bit with it. See what happens. Okay, so I've got the replacement capacitor in. It's soldered on this side, not soldered here. It can work like a switch, and I can even get it to stay there. So we're starting with it off, and oh, I got to hook up the equipment here. Okay, ready. Power on. Let her warm up. AVC voltage is coming up. What's going on with my camera? Is that why I found it aimed straight up there just a moment ago? It could be. Could be I let it float up there without we're knowing it. Maybe you were looking at the ceiling again when you shouldn't have been. So I think I hear motor boating. Nope, it's just that interference. Okay, on the scope, let me turn this down. You really can't see it that way, can you? Okay, hang on 1 second here. I'm going to fix the video up. Okay, that's a little better, I think. There we go. So, yeah, I'm trying to keep this on the voltmeter too. That's a little tough. We can do it like this. Okay, there we go. Tuning the radio, no AVC capacitor. Dropping right down to, this is 5 volt scale here. This is a moderately strong station. If we want to try a really strong one, we would go down here. Here's one. Sound is great.
Where it was very clear,
It's all coming up to about the same level. So maybe when I said the capacitor's job is to get rid of any RF that's making it back, well, that would be true, but maybe it's also trying to knock out any audio stuff that's come back. The RF filter earlier on in the radio near the detector, it can't do anything about the audio. You don't want it to do anything about the audio because you want the audio to make it out of the volume control and carry on. So you're just trying to arrest the RF at that point. So audio can easily make it all the way to this capacitor. And then this is the guy who's got to kill what's left of the audio. Maybe that's a better way of looking at it. So, yeah. Other thing too, I've got this on DC here, and so the AVC voltage is visible right on here. Okay, I'm going to click in the capacitor and we'll watch what happens here. Audio went away. This is bopping up and down in conjunction with the audio. So I think what's done is it's integrated the audio over time. So you're getting a bit of an average, still bopping a little bit. Now let's compare that. I'm going to make this stay if I can. There we go. Okay, so the capacitor's in. I'm going to tune the radio. Say AVC returns to 0, or close to it. The meter says it's not quite 0. Get well up over 2 volts there. And on my meter, it's suggesting 3 volts on the meter here. See, unfortunately, this interference we're hearing, it could be generating AVC voltage also, which is maybe what is here. Well, what if I just take the booster away? Take away some of the noise. This went slightly lower. Probably never get right down to 0. Hey, what if we just try this like this? The booster's 1.5 feet away. So it's just picking up the noise and not much in terms of the station. Is that weird thing there? The AVC voltage not coming up at all. And the noise not really disappearing. But we bring up the loop.
What these things are for there. So if you want to ask the question, is this an appropriate thing?
Of course, the noise disappears because I turn the volume down to compensate for the loud audio coming through. Well, it's interesting. We'll learn something here. Audio being knocked out by the AVC capacitor. Didn't realize that was happening. And without an AVC capacitor, no motorboating. I really thought there'd be a lot of motorboating in here. Surprising. Okay. That's this radio. So I'm going to solder this guy in permanently. And that's it for today. Yeah, that's enough for today, isn't it? That's enough. So there's only one capacitor left here in this radio. So tomorrow what I'll do is I'll do that last capacitor. This one's carrying the audio from the volume control on to the triode preamp here. I'll change it out. We'll tune up the radio and get it to top performance. See what we got. And then I'll go after that guy. Well, that's great. So thanks a lot for watching today. I hope you're finding this interesting. And we'll carry on tomorrow. Have a great day.